So formative quiz next week, Tuesday. Just wrote it. 4 questions. Really good. Not gonna lie to you. I used AI to write one of the questions.
Oh my.
Yeah? Yeah, I did. Because I just wanted to see how it could benefit me. And so I went on the old Chat GPT and I typed in trig simplifying expression, and it popped one up, and I said, nope, harder. And it popped one up. I said, whoa! Tap the brakes. A little more in between those. I'm like, yep, that's the one I like. So, yeah. So one of the questions is written by Chat GPT. And then on Tuesday, February 11th, so a week after your formative, we will then be having our summative on simplifying, solving, and proving. Those are the three topics: simplifying, solving, and proving. Okay. So let's jump into this one. This is a good warm-up style type problem. Okay. Really doesn't matter what symbol we use for the angle. So if you don't want to draw the triangles every single time, that's fine. I get it. Or the delta, if you will. Cosine squared of delta plus cosine squared of delta tangent squared of delta. Bless you. I do also have for you, and I will take one down, pass it around, identities sheets. These identity sheets have your identities on the front and a unit circle on the back. We'll need the unit circles again tomorrow. Yeah, she would have. What do you want to do first? What? Switch tangent? Okay, that's one way of doing it. Yeah, I'm okay with that. So you would say then that this would have been cosine squared of delta plus cosine squared of delta times sine squared of delta over cosine squared of delta. Like that? Yep, I'm fine with that. Then what? So simplify the second term. What does it simplify to be? Sine squared. Delta. And it's just 1, right? Because it's the hammer. Cosine squared plus sine squared is just 1. Okay. Only way to do that problem? No. Could have factored out a cosine squared. Then saw that you had 1 plus tangent squared. 1 plus tangent squared is secant squared. Secant squared is 1 over cosine squared. Cosine squared times 1 over cosine squared is 1 also. Okay. So again, many ways to do these problems. Try that one. I'm going to factor out a sine. I get sine of x. Yay?
Yeah.
Okay. Now, I like this quote from Johnny Cash. Okay? Because learning from your mistakes is a painful way to learn. But with no pain, there is no gain. Okay? So it's okay to make mistakes. I know I say it all the time that I rarely make mistakes. But I make mistakes. I make a lot of mistakes. Okay. So it's a good one from the man in black. Oh, no matter how many mistakes you make or how slow your progress, you are still way ahead of everyone who isn't trying. That's a good one too. Wish it was in a cleaner, crisper font. But. All right, so here we go with today's work. That was a good warm up. Actually, now we get another warm up. Let's try those two. I get signed for the first one, yes? Yeah, okay. I get 1 for the second one, yes? Okay. All right. Let's talk fractions. I know. Oh. Yesterday I dropped factoring on you. Today I've dropping fractions on you. It's just kind of an F-word week. Okay. All right. How do I add and or subtract fractions? Common denominator, right? Okay. So what would the common denominator be for 3 and 5? 15. Okay. So then this is going to become right? And then, so I go like that. Then I got to adjust my fractions. Okay. So 1/3 is what in terms of 15ths? 5 15ths. 2/5 is what in terms of 15ths? 6. Right? Okay. So now I'm there. Now what? Add or subtract the tops. What about the bottom? Keep it common denominator, right? Okay. So then this would become 11 15ths. And then if possible, I would still have to simplify, reduce, all that fun stuff. Okay. Handle? Okay. All right. Now, pick it up a notch. Now we'll take it back to Algebra 1. Same question. If I'm going to add or subtract an algebraic fraction, what do I have to have? Common denominator, right? What's my common denominator in this one? X times x plus 1. Then I got to adjust my fractions, right? What's missing in the first fraction? Got to multiply it by an x, right? What's missing in the second fraction? X plus 1. Okay. Add the tops, right? So the tops then become, oops. Yep, I hit the wrong color. Yes? Can I simplify it? What about? What do you mean? Are you saying I can just whack off those x's? Okay, good, because I can't. No, that's whacking off an x. Can I simplify it? No, because I can't factor anything out of the top. Okay? The only way I can simplify an algebraic fraction is if I factor. Okay? Numeric fraction, the only way I can simplify is if we got a common factor. Okay? So there's a factoring theme there going on. Okay? Let's do a trig fraction now. Okay? The first thing that we need. Common denominator. Okay? What's my common denominator going to be? What? 1 plus sine x, 1 minus sine x? What's missing in the first one? What's missing in the second one? Okay. Now what? Add the tops. What do the tops add to be? No. They add up to be 2, right? Can I do anything with the bottom? No. But they're conjugates, right? Right? One's plus, one's minus. They're conjugates. So what can I do with conjugates? Can I cancel them to their multiplication? So I could multiply them out, right? Okay, what do I get when I multiply the bottom? One minus sine squared. And what's 1 minus sine squared? Cosine squared. I think it's number 7 on your formula sheet, right? Okay. Do I like 2 over cosine squared? Do I like it? How would I just make it be 2 secant squared? Now, with that being said, I will say this. Here's the start in black. Here's the end in maroon. If you don't end here, you're driving to Milwaukee and you pulled off in Fond du Lac and you said, let's go to a Brewer game. Okay? We're in Milwaukee. Actually, you should say the Bucks because the Bucks are in season right now. Let's go to a Bucks game at Pfizer. But you're in Fond du Lac. Okay? So you're along the way, you're just not all the way there yet. Okay? So that's what we're going to be looking for, is that one down there. Okay? Well, try that one. I get cotangent. Questions, comments, concerns, clarifications? I can't make it there. I really can't. Like, you can. Yeah. Did you get the cotangent?
Well, I think so.
Did you have the last 4 letters that you have written down COTX?
I'm not.
So if the last 4 letters
I got
that
there, but I want you to look.
you got there, you got there.
Yeah, but I don't know.
There's 17 different paths to get there because we could have flipped her on tangent.
Yeah, but I
You
don't
know what I
know
mean?
where I put tangent. Oh, that's my flashlight.
I
The
think it's last night.
I don't know where I put that.
They will be posted online too.
Oh, okay.
Yeah.
Where did I put this?
Yeah, let's do this one. Cosine plus sine tangent. Can I do anything with cosine? Nope. Sine tangent is going to be sine times sine over cosine, right? So this is really cosine plus sine squared over cosine. What's up, James?
I know you moved on in the last one, but what did you do with the secant squared x in the last problem?
Secant squared x right here.
Yeah.
Secant squared is tangent squared plus 1. We learned that yesterday.
Oh, is that
It's I think it's number 8. Nope, I lied. It's number 11.
Oh, okay.
Oh my gosh, freaking hammer.
Oh my gosh, it is the frickin' hammer. Yeah. Because now it becomes cosine over cosine, or cosine squared. So the top is the hammer, right? So that's 1. 1 over cosine is secant.
Last time I tried to open the notes, it wouldn't let me open it. Just letting you know.
Were you in the right one?
Yeah, I did it for last student. And it was like user.val.
Were you in first semester or second semester?
Second semester.
Okay, that's probably why. I didn't update second semesters for the last year. Okay. Good. Let's talk complementary angles. What does it mean to be a complementary angle? They add up to be 90 degrees, right? They don't both equal 90 degrees. Those would be right angles. When you add them. Yep, exactly. So when you add them. Okay? So how can I represent two complementary angles algebraically? Let's say the first angle is x. What would the second angle be? 90 minus x. But we live in a radian world. What would that be in radians? So it'd be x and right? Okay. Let's talk right triangles. Okay? Because if we're in a triangle, right? If we got two complementary angles, then the other angle is a 90-degree angle. Let's call this angle A. Let's call that angle B. If this is x, then this is pi over 2 minus x. Agree with me on that? Yeah? Okay. What is the sine of angle A? A over C? We agree with A over C. What is the cosine of angle A? B over C, right? Okay. What is the sine of angle B? B over C, right? What is the cosine of angle B? What can you tell me about those two angles? They're complementary for one, but then the sine of one is the cosine of the other. So if I have two complementary angles, the sine of one should equal the cosine of the other, right? Okay, so these here are equal. If I have two complementary angles, the sine of one should equal the cosine of the other, right? Right triangle trig from way back in geometry. Yeah? So that gives us, on your identities sheet now, numbers 12 through 17, on your identity sheet, if we have an angle and its complementary angle, okay, one angle is x, the complementary would be pi over 2 minus x. The sine of one is the cosine of the other. The sine of one is the cosine of the other. The tangent of one is the cotangent of the other. Okay. And cosecant and secant are also the same. Cosecant of one is secant of the other, because that's sine and cosine. Okay. So those are identities 12 through 17 there. Okay. So now let's put our identity sheet to work. Okay, it's going to be very beneficial for you to have your identity sheet out with you whenever you're doing homework, whenever you're doing in class, all that stuff, because we're going to be referring back to it now the entire time. Okay? Sine of negative x. Give me a number of the identity. Number 2. Okay, so sine of negative x is equal to negative sine of x. Secant of pi over 2 minus x. Give me a number. 17. it's equal to cosecant of x cosecant of x is equal to sine x divided by sine x is 1, right? Times negative 1 is negative 1. Okay. You try that one. I get sine of theta. Yes? Ish? Well, you should have gotten the whole thing. You now have the ability to do all of the numbers 1 through 16 in your HW packet that you should have gotten yesterday.